Hi, this is Daniel Chin, and this is my Lab 1 on constant velocity motion. I took a video of a moving car and modeled it in VPython. My main result from applying Newton's second law was by setting fnet equals 0, the model provided good predictions of observed motion. So here's the video of the car moving, which lasts until the front of the car reaches the edge of the screen. I took the center of the car as the average position and the length of the car to set the scale of the video. The origin of the coordinate plane is set at the first average position with the car traveling in the negative x direction. To predict the motion, I had to first find the mass of the car through a quick search, and it turns out that the mass of the car is 2,765 kilograms. Then I had to find the initial position, which is just 0 because it lies on the origin. Finally, the initial velocity is calculated by plugging into the formula delta x over delta t, and it ends up with negative 10.399 meters per second. So by using Newton's second law, the final velocity is equal to the initial velocity because if velocity is constant, then fnet must be 0. And then plug this into the model to predict the motion. So here is the model showing the predicted motion. The car starts at the origin and then moves to the left in the negative x direction, and that is also seen in the graph. The data from both the model and the experiment are plotted here on a graph in Excel. Blue dots represent the experiment and the red line represents the model. Time is on the x-axis with position on the y-axis. As you can see, the model and experiment are nearly identical. So what if the motion was in the positive x direction? The only difference is that the velocity is positive and the graph would look different because position would get more positive over time as opposed to being more negative. Finally, what does this all mean? So if velocity is constant, then fnet must be 0. This implies that if fnet is not 0, then velocity is not constant. Plugging this into the model, the graph has a curve and is no longer linear. This suggests that the speed and/or direction is changing.